experiment is to determine the wavelength of microwave using expand microwave bench that we use working in the TE10 mode, that is transverse electric mode. So this is the circuit diagram, you can say. In this way the parts are arranged, that the Kleston tube is there, then the micrometer is there, then frequency meter, then variable attenuator, then the slotted line section, micrometer, and this is match load, you can say, variable or fixed short circuit. In this way the different parts are arranged. Some will be used here and some will not be used. Now in this way the parts are arranged. Kleston tube that we already discussed. This is Kleston tube, that is a fan. This is isolator. This is the frequency meter. This is variable attenuator. So I will discuss later on what are the functions. This is the slotted line section. This is the power supply, and this is the micrometer. That the brief here. In this way the parts are arranged. Now different functions. Isolator, which is there, that function is it opposes the microwave signal only in one direction. It blocks the signal if it is coming in the reverse direction. It blocks it. Similarly, frequency meter will be used to measure the frequency that we are not using here. The variable attenuator is there, that decreases the strength, that as the name says, variable attenuator. So that will mean it will attenuate the signal, right? Similarly, this VSWR meter, voltage standing wave ratio, that we are not using here, it is there. Matched load is there, that will terminate the transmission line or wave guide, so that all energy from the signal source will be absorbed. Now the slotted line section is there, that is used for the purpose of measurement, that we will see later on. The attenuator is there. Two type of attenuators are there, fixed and variable. We have variable here, variable attenuator is there. Then the expand is basically 8 to 12 gigahertz and needed to 3 centimeter. It can be somewhat smaller or somewhat bigger also. This is the order only. So that is the range for this expand. Now, first of all, parts are arranged. Hardly it is arranged there. So in this way it is attached. Then so before starting anything, that is basically the important, you can say, to turn off fully anti-clockwise. What? Beam voltage. Beam voltage should be minimum anti-clockwise, right? And then the repeller voltage should be maximum. Similarly, this amplitude knob for modulation point should be fully clockwise, and the frequency knob at a mid-vision. Then the repeller voltage should be 265 volt, not more than that. All these precautions are basically required before switching on the power supply. So please check these things are there. Otherwise, what will happen? This Kleston tube may burst also. So these precautions you have to take. So these are the repeller voltage move slowly, right? So that deflection is there on the micrometer. If no deflection is there, then some adjustments are there, like plunger, length of the wire, that we can change also. Similarly, this reading on the micrometer should be of this order, not more than 35, and it can be 15 to 35, right, approximately. So similarly, to reduce between more than 35, then you have to reduce it by using the attenuator. Similarly, distance between two consecutive maxima or minima that we know, that is half of the wavelength. So if you want to measure accurate value, then the oscillator method is there. that is the separate method is there, that you can use that also. So here, before switching on power supply, again I am repeating same thing which I have said earlier. So these are the minor adjustments. This beam voltage should be minimum, fully anti-clockwise. This should be clockwise, and this reading should be near to 265 volts repeller voltage. This amplitude should be this fully clockwise, and this frequency should be in the mid position. So here amplitude modulation should be, this point you should select, and here repeller voltage. These are the adjustments before starting the practical. Now this slotted line section will be using. So here the main scale, vernier scale, which we have to use for my reading. You know the method. This is a main scale and this is a vernier scale, so that can be used for the purpose of reading, right? The least count, how the least count of vernier constant you can say, we have to use that. We will see later on in the calculation part. We will measure. So this is the attenuator, wave attenuator. We can move this one to produce a signal, or you can say to reduce the reading on this micrometer. Similarly, if no reading is there on micrometer, I repeat, if no reading is there on the micrometer, only it should be, then this is plunger on the Kleston tube. A very small knob is there, that is plunger. Don't change it much. Reason, the Kleston tube will burst otherwise. Similarly, this is rotor line section, where inside it small wire is there, that length we can change if no reading is there on the micrometer. This is a micrometer. Here the least count of micrometer is 0.5. Least count means minimum reading which we can measure with the help of this one. Beam voltage, I already said, it should be fully anti-clockwise. This is, I am repeating, this should be just in such a way that 265 proximity is there, right? This should be fully clockwise. This should be in the mid position. So that I already discussed. So now this is a fan. I have already said the fan should be on always for using the Kleston tube. Otherwise, Kleston tube will burst also. Right? I am repeating again and again. Kleston tube is a very delicate tube. Right? So precautions are basically for the safer side. You can switch off this power supply after 10 minutes, so that it cools down. This isolator is there, that I already discussed. This is a Kleston tube. This is a slot line section. This is a video basically. How we are using. I am moving this one. You will see reading is there on this micrometer. I will measure the reading from here only. The purpose of at maxima or to minima, the reading can be measured. How this video works. You can moving here. You can see this pointer on the micrometer is going further, going maximum, then now come back. So two maxima or two consecutive maxima or minima we will use for my reading. So that is the waveguide. So two consecutive minima or two consecutive maxima you can see to measure the this LG by 2, wavelength by 2 of the guide wavelength. That is the first of all least count you can measure. One main scale division or divided by total number of divisions on the vernier scale. that is 1 mm by 10 meters, that is 0.1 mm or 0.01 centimeter. So two consecutive maxima. This two consecutive, this one 9.82, this one also. Similarly, two consecutive minima, this one. Any two you can take. Two consecutive maxima, this one and this one, that is there. So that is lambda g by 2. Similarly, two consecutive minima, that is there. So you can take the average also, right? That is the, then you can see that was the value, lambda by 2, 9.72, 2.7, that is 2.36. So multiply by 2, because this is lambda by 2, this is lambda. So that is the wavelength. Approximately, if you take the average, that is equal to 5.06 centimeter. Thank you.